Okay, class, today we're going to revisit our special quadrilateral. We're going to start with the parallelogram family. Now, we've already looked at this in terms of what it would look like on the coordinate plane. We found perimeter, we found area. If given 3 of the points, we found the 4th vertex. So we've already dealt with parallelograms for a while. So today we're going to look at them in terms of some of the proofs and some of the algebraic things that we can do with them. So keep in mind, let's remember, any polygon with 4 sides is considered a quadrilateral. However, some quadrilaterals have special properties, and those special quadrilaterals have their own names. So today we're going to revisit the first one, the parallelogram. A quadrilateral with 2 pairs of parallel sides is a parallelogram. So that is the definition. A quadrilateral with 2 pairs of parallel sides is a parallelogram. And we, to write the name of a parallelogram, we actually use the little symbol that looks like a little tiny parallelogram. So here's parallelogram, A, B, C, D. Here's the little symbol. And we know it is because we see 2 pair of parallel sides. AB is parallel to CD, and BC is parallel to DA. So if you would like to follow along with me today, I'm using a good bit of the examples out of your textbook. We're in Module 7.1, and we're also going to finish up in 7.2. So we're starting on page 209, and you can flip through with us. I'm not going to tell you the page number of every page, but we're in Modules 7.1 and 7.2 today. The first thing we're going to do is complete this proof here. It says, given JKLM is a parallelogram, prove that JK is congruent to LM and KL is congruent to MJ. Well, we were given that JKAM LM is a parallelogram, so that was given. Now, by definition, what does a parallelogram have to have? Parallel sides. So if we look at step 2, that's what it's saying. So our reason for step 2 would be definition of a parallelogram. So when we have parallel lines, if we have this transversal drawn in, we know lots of things about parallel lines cut by transversal. So when we look at angle 1 and angle 2 being congruent, and then 3 and 4 being congruent, those are alternate interior angles. So alternate interior angles are congruent. And JL is congruent to itself, reflexive property. We've seen that one over and over again. Therefore, we've proven congruent triangles. Triangle JKL is congruent to triangle LMJ. And let's mark our picture, so see if we can figure out what this is going to be. So we have this congruent to this congruent to this, and JL is congruent to itself. So I see an angle, a side, and an angle, a side, and an angle. These are congruent by the angle side angle. And then because they're congruent, we know that all the corresponding parts are also congruent. So we can say JK is congruent to LM and KL is congruent to MJ by corresponding parts of congruent triangles are congruent. All right. Now, these are some things that we know must be true given the parallelogram. If a quadrilateral is a parallelogram, then its opposite sides are congruent, and we could prove this. Just did. Corresponding parts of congruent triangles are congruent. If a quadrilateral is a parallelogram, then opposite angles must also be congruent. Well, we could prove this by drawing in the 2 different diagonals and proving 2 different congruent triangles. Corresponding parts of congruent triangles must be congruent. So we know that opposite angles must be congruent. If a quadrilateral is a parallelogram, then its consecutive angles must be supplementary. Well, yes, they have to be. They're same side interior angles. They have to be supplementary. If a quadrilateral is a parallelogram, then its diagonals bisect each other. We could prove that using 4 congruent triangles here. Okay, so let's take some of those things we've just talked about, and if you're following along in our textbook, we flipped over to actually the homework section, so we're now on page 214. All right, so let's look at 31. Says complete each statement about parallelogram, so it tells us it's a parallelogram, and justify your answer. The first one, angle MPR. MPR. That's this angle right here. What must it be congruent to? It must be congruent to RKM. RKM. Those are opposite angles. I know that opposite angles of a parallelogram are congruent. Okay, now let's look at the next one. PRK. PRK. Well, its opposite angle is over here, so it is congruent to angle KMP, because opposite angles are congruent. Number 34, MT. MT is right here. It must be congruent to RT. How do we know that? Because we know that diagonals of a parallelogram bisect each other. And when it bisects, what's the definition? Breaks it into two congruent parts. PR must be congruent to MK or KM. How do we know that? Opposite sides must be congruent. The next one, MP must be parallel to KR. And we know that because that's part of the definition. We have to have two pair of parallel lines. MK and PR must be parallel. MPK is congruent to, well, these are alternate interior, so it's going to be angle, I bet you can beat me to it, RKP. RKP. This has to be congruent to this. Okay, MTK, this one, must be congruent to what? This one. Angle RTP. This one's vertical angles, so that's not one we've talked about. And then this one, the measure of MKR, so let's mark that. MKR, this one right here. And the measure of PRK, this one here. Those are consecutive angles. Those are consecutive angles. And consecutive angles end up being same side interior, so they must be supplementary. Okay. So this is a real quick, easy thing. If this is 61, then this x has to be supplementary to that, so it is 119. And if this is 61, the opposite angle is 61. If this is 119, the opposite angle is 119. Okay, if this is 53, the opposite angle would have to be 53. Now this forms a little triangle, so this would have to be, what does it leave us for y? 37. And if this is 37 and this is 53, how can we figure out x on number 42? Well, we know that this larger angle, the angle addition of those two, would have to be the supplement of 53. So we can subtract from 180 the 53 together with the 37. And so for 42, we get that this is 90. Now, you know what? We didn't even have to go through all that because these are alternate interior angles. So if this is 90, that also must be 90. Did it the hard way that time. Okay, let's skip to 44. They ask us to complete this paragraph proof. It says ABCD is a parallelogram. Prove that AC and BD bisect each other at E. So for this one, AB is parallel to CD. All right, and if we keep reading, that's by the alternate interior angle theorem, angle 1 would have to be congruent to angle 2, and then angle 3 would have to be congruent to angle 4. Now, why is that? Once again, because of the alternate interior angle theorem. It goes right here again. So this means that we have congruent triangles. Why is that? Okay, we have congruent triangles. Let's mark our picture and that'll help us see it. This is congruent to this. this is congruent to this. And it tells us that, oh, I skipped one. That's why. AB is congruent to CD. And how do we know this, that AB is congruent to CD? We know that opposite sides of a parallelogram must be congruent. So now we have this is congruent to the other by angle, side, angle. Okay, so once we have proven congruent triangles, then we can prove that these are corresponding parts of congruent triangles must be congruent. And we can't really see the rest of this real clearly. Let's see what it says in our book. It says, so by blank, AE is congruent to CE and BE is congruent to DE. So, AE, corresponding parts of congruent triangles must be congruent. CPCTC. Therefore, AC and BD bisect each other. And that's the definition of bisector. Okay. Now, in the next section, it's going to take it another step further. So, in the first one, if it's a parallelogram, all this must be true. So, if P, then Q. Now we have our converse of those theorems. So, if we have one pair of opposite sides that are parallel and congruent, then we have a quadrilateral. If we have both opposite sides congruent, then our quadrilateral is a parallelogram. If both pairs of opposite angles are congruent, then our quadrilateral is a parallelogram. So just like the other day when we switched our hypothesis and our conclusion, that's what we're doing here. These are our conditions for our parallelograms. They are the converse of the theorems we've already discussed. So this next one, if an angle of a quadrilateral is supplementary to both of its consecutive angles, then the quadrilateral is a parallelogram. If the diagonals bisect each other, then the quadrilateral is a parallelogram. And this is summarized for you on the little half sheet you received today. So once again, here they are summarized for us. So we're supposed to show that this is a parallelogram for x equals 3.2 and y equals 7. So to show that, when we plug in 3.2, we better get an equivalent statement here and here. So if we solve this, what should it better equal? 3.2. So we'll move this over here. We'll move this over here, and 16 divided by 5 is 3.2. It shows they're equal. Okay, y better equal 7. So if we set this equal to this, then y is going to equal 7 if they're equal. So we get 7y equals 21, y equals 7. Ta-da! Okay. Now these are a little more interesting. Did they give us enough information to determine if we have a parallelogram? All right, we have 4 congruent sides. Do you see that we have both pairs of opposite sides are congruent? Check. Is that enough? Yes, it is. Okay, let's look at this one. Now, did they give us one like this? No, but when we look at it, angle, side, angle, angle, side, angle. That shows congruent triangles. And with congruent triangles, we know that opposite sides must be congruent. Is that enough? Yes, it is. Okay, let's take a look at this one. We've got an angle and an angle. Oh, we got another angle up here too, because we have vertical angles. Do we have any congruent triangles going on here? I don't see congruent. I see similar. This gives me similar. I can't prove opposite sides are parallel. I can't do this. I can't do that. I can't. No, 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 no. No. If I say no to all these, I cannot determine that it is a parallelogram. Okay, let's take a look at these. Skipping down to 17. Is this enough on number 17? Okay, I see supplementary, so let's look. One angle is supplementary to both of its consecutive angles. Did they give us both? Nope, not enough. All right, so let's look at 18. On number 18, do we have enough? All right, we've got vertical angles. Nothing's marked. I can't tell this. I can't tell that. I can't prove 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 anything. No. All right, on this one. This time they gave me the lengths of my diagonals. This one's bisected. This one's bisected. The diagonals bisect each other. Is that enough? Yes, it is. Okay. Now, algebraically, what would we do on these? On this one? Because they're telling us to find the values that would make it a parallelogram, all you do is set this equal to this and solve. That's all you do. On this one, we would take these two and add them and set it equal to 180. Then we found A. So let's do this. Here we get 12A minus 18 equals 180. So 12A equals 196. So A equals, goes in there one time, and, 198. That might work a little better. And then, is this going to give me a, oh, it does. It gives me a little bit of a decimal. So we get 16.5 for A. So we'll plug 16.5 in, get this one subtracted from 180, and that's what we'll set this equal to. Okay? On these, you can set 2A equal to 3B minus 5, because this is bisected, it must be equivalent. And you can set 3B plus 6 equal to 5B minus 7. Solve for B, plug back in, get your A. On this one, if this is a parallelogram, then alternate interior angles must be congruent. So we can set this expression equal to this expression and solve for A. Opposite sides must also be congruent. So we can set this expression equal to that expression and solve for B. Okay, let's look at one more proof. AB is congruent to CD and BC is congruent to DA. BD is congruent to itself. That's the reflexive property. Therefore, triangle DAB is congruent to triangle BCD. By side, 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 congruence postulate. So, because corresponding parts of congruent triangles must be congruent, angle 1 must be congruent to angle 3, and angle 4 must be congruent to angle 2. So now, these are my alternate interior angles. So those lines must be parallel because alternate interior angles, the converse of the alternate interior angle theorem. Therefore, ABCD is a parallelogram from the definition of parallelogram. All right. Now you should be receiving this if you haven't already. Today we're just doing parallelogram. Next week we'll work on our specials.